With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is, the following equilibrium constants were determined at 1120 Kelvin. First is 2CO plus gives carbon solid plus carbon dioxide. Kp1 is 10 raised to power minus 14 per atmosphere. Second is CO gaseous plus Cl2, it forms CoCl2 gaseous. Kp2 is 6 into 10 raised to power minus 3 per atmosphere. What is the equilibrium constant Kc for the following reaction at the same temperature? So that is carbon solid plus carbon dioxide plus 2Cl2 forms 2Cl2 gaseous. Now we are given here two reactions whose Kp's values are also given, and we have to find out the equilibrium constant for this reaction. So first reaction is given 2CO gaseous, it is giving carbon solid plus carbon dioxide gaseous. Its Kp value is given. Kp1 is 10 raised to power minus 14 per atmosphere, and second equation is given CO gaseous plus Cl2, it forms CoCl2 gaseous, and its Kp2 is given 6 into 10 raised to power minus 3 per atmosphere. Now we have to find out the Kc for this reaction. So from, let's say this is reaction 1 and this is 2. If we reach to this reaction, we can find out the Kc. So if we see that here the carbon is on the right side, here it is on left side. So if we invert this reaction and invert this reaction first, so we will write reversing the reaction 1. So if we reverse the reaction, it will become carbon solid plus carbon dioxide gaseous. It will form 2CO gaseous, and its Kp value, let's say Kp1 dash, it will become 1 upon Kp1. So it is 1 upon 10 raised to power minus 14 per atmosphere, which is equals to 10 raised to power 14 atmosphere. Now second reaction is this. So if we multiply this reaction by 2 and add to this reaction, let's say this reaction we have as 3. Now we have to multiply the reaction or equation 2 by 2. So it will become 2CO plus 2Cl2, it forms 2CoCl2 gaseous. So its Kp2 dash, its value will become Kp2 square, because when we multiply the reaction by a constant, it will raise to power to the new stoichiometric coefficient. So it will become 6 into 10 raised to power minus 3 per atmosphere square. Now we have equation 3 and equation 4. If we add these equations, we will reach to this final equation for which we have to solve the equilibrium constant. So now we will add these reactions as carbon solid plus carbon dioxide gaseous. It will become 2CO, and its Kp value, Kp1 dash is 10 raised to power 14 atmosphere, and this reaction is 2CO gaseous plus 2Cl2 gaseous. It forms 2CoCl2, and its Kp value, Kp2 dash is 6 into 10 raised to power minus 3 atmosphere per atmosphere square. So if we add this, these will get cancelled, 2CO gaseous. So we will have final reaction, that would be carbon solid plus carbon dioxide gas plus 2Cl2 gas, it forms 2CoCl2 gas. Now if these reactions are, If these reactions are added, it means their equilibrium constants, they will get multiplied. So we have to find out Kc for this reaction. So if we find Kp for this reaction first, we can find out Kc. So we will find Kp, we will write it as Kp. So that is equals to Kp1 dash into Kp2 dash. So this will become 10 raised to power 14 atmosphere into 6 into 10 raised to power minus 3 per atmosphere square. This will become 36 into 10 raised to power 8. This is atmosphere and this is per atmosphere square. So it will be in per atmosphere. It's Kp value. This Kp value is for this final equation. Now we have to find out the Kc value. So there is a relation between Kp and Kc, which is Kp is equal to Kc RT power delta Ng, where Kp is the pressure equilibrium constant, Kc is the concentration equilibrium constant, R is gas constant, T is temperature, and delta Ng is the change in the number of gaseous moles. Now if we calculate delta Ng for this reaction, that would be the number of gaseous moles of product is 2 and number of gaseous moles of reactants are 2 plus 1, that is 3. It means 2 minus 3, because the gaseous moles, this is gaseous moles of products minus gaseous moles of reactants. So it is equal to 2 minus 3. It means it is minus 1. So now we have delta Ng is minus 1 and we have to find out Kc. So Kc will be Kp divided by RT power minus 1. Now Kp value is with us, that is 36 into 10 raised to power 8 per atmosphere. Now it will become Kp. If this will come in numerator, it will be positive 1 power. So R value is 0.0821 liter atmosphere per mole per Kelvin. This is the value of gas constant into temperature, that is given 1120 Kelvin. So this Kelvin is cancelled by per Kelvin, per atmosphere is cancelled by atmosphere. So we have value in liter per mole. Kc is in liter per mole. This value is equals to 3310.2 into 10 raised to power 8 liter per moles. So if we divide and multiply this by 1000, it will become 3.31 into 10 raised to power 11 liter per mole. Now mole per liter, this is known as molar. So it will be liter per mole. It is 3.31 into 10 raised to power per molar, because it is inverse of this. So Kc for the final reaction we have is 3.31 into 10 raised to power 11. So the correct option to this question is A option, 3.31 into 10 raised to power 11 per mole. I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.